let me briefly introduce you. Your speech will be a look back at the disposal project to date and a forward look at the need for stewardship. So you are Marcos from Switzerland. You're an engineer, I understand, and a geologist and a scientist, and you have a long standing career of consultant of experts, and you have been involved in the management of industrial and radioactive waste project, and being also a member of several scientific commissions in Switzerland. So you also in France were a member of the Stocamine steering committee. Stocamine is a, you will introduce it. It's a place where some chemical waste are disposed. Um, Maybe you will not use the term dispose. I leave it to you, but I think basically I'm now ready to give you the floor, Marcos.
First of all, I would like to have some comments. The first is thank you, Robert, for your presentation, because your photographs are really a possibility to see what I will comment on the technical side. And that is a perfect introduction to my speech. And it's really impressive what I saw that. The second quick comment is thank you also Reinhard Überhorst to have joined this presentation. And I hope that it will be possible for you to join us in the future. So now for this, my part, I would like to give you a look back at the disposal projects to date and the forward look and the need for stewardship in the future. So first I will, oh voila. Yes, now how, yeah. So what I want to say is where does nuclear waste management stand today? Because we hear that in several countries like Sweden, Finland, France, even Switzerland and Germany, the problem of waste disposal or site selection is more or less solved. And that is a really big propaganda action, and it should be questions. And I think that is one of the aim of my presentation. So what distinguishes today's project from early project phases, or in other words, what have disposal planners learned from their failures, and what have they not learned? Then what effects have this question on the reatomization effort and the actual reatomization effort, and what is the role of the disposal project in this sense? Then how robust is the concept, the actually only pursued concept of a deep geological repository at about 500 meters, and what are the fundamental weaknesses of modern disposal project? And at last, what is the importance of monitoring and stewardship? And you see that in contrast to the presentation of Robert, is really a presentation which is focused on, I would say, technical and scientific points. Next. Well, so we will look on three parts. First, a quick look back, some examples of former disposal practices. Thank you, Robert, because I will speak two from Hanford and all the sites. Then failures and findings in this first section. Then in the second section, I'll look forwards, the key issues and the unresolved problems and ways to deal with complexity. And then at the end, an outlook on governance and safety culture, the need for error correction and reversibility of decisions, and how to deal with long-term stewardship. Next, well, you know probably the warnings, that is the first slide, the early warnings related to social acceptance and technical feasibility reported by Alvin Weinberg. There are two very interesting warnings. The one was from Enrico Fermi. He questioned the acceptance of nuclear energy by saying, well, we produce so much radioactivity and we are not sure that society will accept that. And the second one, that was James Conant, president of Harvard, which stated in a presentation in 1951 that nuclear energy would not be worth a candle because the problem of radioactive waste was intractable. I think that is really fantastic, this far-sighted analysis from these people. Conant was a chemist, and in this sense he was maybe a little bit more aware of the chemical side of the problems. So let's go to the first part, the look back. Yes, Malcolm? Well, now there is a slide from a typical dispersion pattern for effluent from one plutonium reactor at Hanford site, and it shows how in the early days radioactive waste disposal had been done just by dilution in the Columbia River, and that is a really impressive picture also, because it shows that was over and over in every country which used nuclear material, that was the same on every part. Next one. The same thing with the disposal in Hanford now, directly dilution into swamps, or then this waste was put into trenches, or the higher radioactive waste, the hotter waste, was disposed in boiling tanks and then joined cribs where these liquid wastes were diluted, and they reached then the water table and later the Columbia River. Next one. So that is a very interesting image or interpretation which has been used during decades. You will find it in many articles, and showing what scientists to that time thought that the harm was of diluting this waste was relatively little, because plutonium or rare earths was retained, and the other one was elements, radioactive elements like strontium or cesium, was a little bit quicker in the movement, but more or less soil could retain radioactivity. Next one. Then the next step was then after the big discussions mids of the 50s and report 1957 of the National Academy of Sciences, that was to focus on disused mines and especially disused salt mines in order to dispose radioactive and especially high-level waste. And that was the first big project in the United States, Project Saltwald in Lyons, Kansas, which was abandoned then 1972, when it became clear that a series of old boreholes hadn't been plugged and water could join the old salt mine. That was the end of the project. And that was really interesting because that was a planning error, a classical planning error that knowledge had not been well ausgewertet, used. Next one. No, next one. Well, let's the next yes, that is that there are the first experiments with thermal load in also in one of these caverns in the Kari salt mine. Next one. The next big experiment was in Asse. You see two pictures on the right side with disposal of low-level waste in drums on the lower part and of intermediate level waste. And that is, I think, everybody here knows the big problem of this site of Asse, and at that time the whole industry and the whole experts were convinced that that was the right solution. Next one. Even here, a brochure from the International Atomic Energy Agency, which made appear a little PR report, radioactive waste from where to where, and it shows the mentality to that time. That was 1977, and people was really convinced to have found a solution to the problem. And there has never been a response, for example, from the official bodies, NAA or IAEA, to such publications that show that they had been wrong. Next one. Then you know the ocean disposal in the Atlantic, 69 to 72, to 82. Yeah, next one, and the end. Other type of disposal activities here. The US Ecological Disposal Facility in Beatty, Nevada, which had been thrown in big trenches. Next one, with in drums, in metallic drums that had been covered by earth material, and where big machines was rolling over and damaging the yeah. And you see afterwards, next one, that was an explosion in Beatty in the Trench 14, there was in 15 October 2015 a series of explosion and a formation of a really big hole. After this explosion, after rainfall and a reaction between water and the wastes which have been buried there. They are not only radioactive waste, but there are also chemical waste, and that shows the impact for the future, because such an event can happen to every time in the future. Next one. Here you have a cross-section of the first project in Switzerland in the old gypsum mine near the Rhine. It's a geological section, gypsum mine, exactly. And this, you see the yellow lines here, and that is the niveau of the different niveaus of the caverns. And you see that the karst, so the open holes and fractures, reached also this mine niveaus. And that would be absolutely inconceivable today to choose such a site for repository of radioactive waste. It was conceived even to have the disposal of high-level waste. It's incredible, things like that. Next. And then last example, that is weep. I think many people know the problems of weep, but I would like to address some of these problems. Next one. See the installation on 650 meter in depth, and you see how waste are stored. So they are placed in some packages, and there are a big varieties of waste and clothing, tool equipment, sludges, soils, all contaminated with radioactive materials. Next. WIP has been named the flagship of the waste disposal projects in worldwide. And then in 2014, in 9 days, there were 2 big accidents. The first one was not so, basic problem. That was a fire on salt hold track, but it showed that the HEPA system, the filter system, which was intended to filter out radioactive particles in the air in the case of the accident, was not working. And that was a big une grande chance, a big
opportunity.
Yeah, that this accident occurred, because 2 days before the second accident came, the HEPA filters was worked correctly, more or less correctly. Next one. Here the second accident, of 14 February 2014, one container that exploded, and it's 200 or 55 gallon big, and he this explosion contaminated a third of the whole repository and led to 3 years of closure of the mine. You have to be aware that material, this true waste of military sites like Hanford and Rocky Flats and Los Alamos Laboratory and that were all waste from the military production. I forgot to say that are many of them containing nitrate salts from reprocessing. That was one. Yeah, next one. And then I would like to address one big problem you saw in one former slide. You saw how waste had been placed in these galleries. And here you see now a typical roof collapse of mines, and that is what is probably the normal process. Not the flowing of salt, but collapses of salt that will damage the canisters that had been put inside. And that is evidently, such things are the end of the idea of retrievability that is sold by nuclear industry. Next one. So, very quick, the major finding, all attempts to develop sustainable disposal projects fails. And at the beginning, we had hair-raising disposal practices, waste disposal out of sight, out of mind. There were conceptually very weak projects, no basic or fundamental analysis of processes. And here's evidently the people which is working actually on waste disposal, they learned that that was not possible to plan in this way in the future. The projects but are still built on the trial and error principle. So the learning processes are very, very slow from the old idea of disused mine repositories via modern burial in underground repositories in 500 meters depth. But there was no fundamental shift away from general concept, but just a further integration of corrections. For example, the safety analysis, the beta selection process, the possible retrievability, or the inclusion of monitoring. But the idea to put that on some depth had not changed since more than 60 years. And what is very interesting and a fundamental lack is no real accompanying process measures as error and safety culture. Next. Next, we go to next, Malcolm. Thank you. So it's in some way what you showed, Robert, just with some pictures of sites, but the result is the same in underground. The problems are still here for the next generations, and that leads to the question how planification processes should be in the future. And I would address two things, the key processes, the key issues of unresolved problems. and the ways to deal with complexity from a lot of, from several questions of these types. Here is a representation of the Swiss program, the nuclear power plants. In the upper part, this yellow or orange bulks, and in the lower part, the brown things. And this figure shows how the Swiss program dealt in the past with his radioactive waste. So in 1979, it was assumed that we would have in Switzerland as well a repository for low and intermediate level waste as a repository of high level waste. And that was the beginning of a series of predictions when the different repositories could be opened. And you see very quickly that all these timetables, weren't c'était pas possible. That was not possible to fulfill them. And you see, for example, here in 2007, the opening of the disposal facility was predicted for 2040. And 7 years later, we are in 2060. And that had huge consequences, this failures in the planning process, because you had to install intermediate Zwischenlager, intermediate,
in French.
Excuse me.
Yeah,
intermediary storage facility, perhaps.
Temporary storage, exactly. Yeah. That was next. So you see, we have still, that is an image of La Hague, and next, one of Sellafield. And these two pictures shows the basic problem. On the one hand, the wet storage on the one side, and the other big problem is you have corrosion processes with this wet storage, and these wet basins are not protected, for example, in Sellafield. And the risks that of wet storage is particularly high. Next one. But also the dry storage that is practiced today has, on my view, very high risk. On the upper side, the Swiss Rolls-Royce temporary storage of Zwilag, and on the other image is an American interim storage site. And I think that is really a big problem to store high-level waste in this way, the spent fuel. Next. And to store it temporarily over decades and decades, just under excuse me, under the sky. Okay, so what I want to show you also, that these slow learning processes, until until 2000, the idea of the nuclear industry and the different bodies which was involved in these programs was to realize a definite repository without monitoring. That was a project that is still pursued in Finland. Practically, we know what we have to do. We can dispose directly, close the repository, and then forget. And that was questions to the first time in Switzerland with this commission, with the ECRA commission, which introduced another first time, another concept with a pilot facility with a part of the radioactive waste, which should be then monitored during hundreds of years if that would be necessary. And the main facility could be closed very quickly. This concept is in this sense interesting because it has been introduced in the law, in the Swiss law. Next. But what this concept didn't analyze, that is the way between the interim storage and the final geological repository. I think that was a big error because all the experiences we made until now in several places as WIP, but also in the chemotoxical field with Stocamine and other facilities, that this concept doesn't work, has not been introduced in this, this analysis. And I think that is the weak point of the whole conceptual of the whole concepts for radioactive waste disposal pursued until now. Next. So the strategy of final disposal have never been fundamentally questioned by nuclear industry, but also by the governments and the control bodies. So there is still a strict adherence to the idea of abandonment, which with untested recovery options, so retrievability plans. And this is a key issue because abandonment is unacceptable. And I think Gordon spoke the last time exactly on that topic. Then the poor planning processes, pushing out implementations and creating poor interim storage strategies. And the discussion is still open about the own waste management strategies. And then no mature interim storage strategy, the dry storage in underground facilities with monitoring and maintenance. And this strategy of surface storage is unacceptable. And we see actually all the risk in the war between Russia and Ukraine. Next. So some fundamental open questions we will have to address in the future in all these disposal programs. The first one is the presence of bomb-grade material that we put inside at a depth of 500 meters or 600 meters underground. And that is really 500-600 meters depth is no protection against intrusion in the future. Then there are a big variety of radio and chemotoxic and reactive materials. Both things had also been addressed from Gordon the last time with plutonium, the plutonium isotopes, and the disintegration in uranium-233. Then really this extreme big variety of materials and chemical reactions that are possibly in such a disposal site. Then the induction of reactive processes, gas generation problems, underground fire hazards. You saw WIP, but we have the same problem in Stocamine, in this chemotoxical site, or as I showed you in BT in Nevada. And another reactive process is the introduction of a high temperature pulse in the underground when you store high level waste. And all that is a big uncertain waste body that nobody is really understanding. And what is really makes fear is that no monitoring concept has been adopted to such a strategy. And I want to give you some examples now of that. Well, you see here the variety of canisters with steel and with different heavy metals, concrete. Next, especially when you see the huge material of organic waste components with bitumen, PVC, resins, etc. That is really a big problem in gas generation. Next one. No, next one. Next one. Yeah. Another. Next one. Next one. Next one. Then, for example, in the France or also in the Swiss concept, the package made of polypropylene fiber reinforced concrete and drums of bituminous waste. And bitumen, you know that it takes fire with some temperature, 20 degrees or more, and that is a material that can take fire, and that is not a suitable material to put it into an underground repository. Here we have some pictures of the Swiss concept, how to dispose more or less 25-ton heavy canister on bentonite blocks. And just that is the comment on that. In little PR films, that is very easy to show how it works. But if you should put these canisters inside, really inside a gallery, which is in the case of Switzerland, 800 meters long, that is no experience as with this technique, no experience with the filling of bentonite. There are big problems actually to realize that. Next one. Here, this model of the Swiss, the way they want to put the canister inside. Yeah. Here, a picture from the Monterey research laboratory, where big experience has been realized after some 10 years ago they started. And that is a thermal experiment with 3 canisters which are heated artificially. And it was really a big problem to put inside this 6 to 8 ton weighted canister. That was really I can tell you, people was around. So if you should do that with radioactive waste, people would people which stands by would have been killed. So that is for me this type of experiments which was said to be a model how to put canisters inside the storage gallery are simply propaganda. Okay, next. So here a little picture on how the galleries are protected against rockfall. And that leads to here the next picture of Monterrey, which shows the big pressures of in the underground laboratory, and the need of
Holding back?
Holding back with cement and reinforced structures. And that is a really big problem also in all these underground disposal sites. Next. So the next point is, for example, the formation of excavation damaged zone. That is a big problem as well in granite and as well in argillaceous formations, because this in salt a little bit lesser, because this excavation damage zone is open hundreds to thousands of years. And in fact, there is an inflow of water through this excavation damage zone must be considered as realistic. And that would be basically a very bad scenario on safety. Next. Yeah, here just also one, or we can go to the next. Yeah, here just an example of the Swiss program. You have the caverns are filled with containers, and with the open spaces are filled with mortar. And that is a big problem if you fill the caverns with a material that is stiff. And stiff material in a clay material that could move is really a safety relevant weak point. Yeah, next. You see here that there are immense cross sections. Here you see 11 meters on one side, 13.2 meters on the other one. So that are big caverns. And for Opalinus clay, as a Swiss program, that cannot work well. The whole formation of faults and fissures where water could circulate is very, very big. Next. Then, evidently, the challenge to deal with complexity and time. And this challenge are very big, and why there is not other method, please, next. What is done is to work with modeling and safety analysis, and evidently safety analysis ignores some processes, and I would like to show you one of these processes that is never really discussed, that is the advance of techniques in the future. So the concept reviews of the concepts today pursued does not review these things. For example, the technological advancement of borehole or shaft sinking techniques. And you see here an example of such a vertical shaft sinking machine that are in the mark today. That is a machine from Herrenknecht. It's a German company. And it works in every rock, maybe not granite, but in sedimentary rocks is no problem. And in diameters reaching 18 meters, that is absolutely a big hole that is realizing. It's used also for tunneling to make shafts in the case of tunnel projects. And that shows the big problem of intrusion in the future if you admit that technology will advance. Next. So the big problem that we have in this big time scales are that safety analysis as a method is not a good tool, or is in any case not sufficient for long-term predictions, and we don't have anything other. And all is based on safety analysis. And in the last years, the nuclear industry addressed increasingly the problems of uncertainties. That is very interesting because this question had been raised since 30 years by critics, that you couldn't bury uncertain processes in the underground. But the consequences today are not analyzed and drawn. And I think we need to address, in this sense, new conceptions of waste management and societal implication in order to develop better solutions in the future. But we cannot realize, on my view, a disposal site today with the knowledge we have today. And that doesn't mean that we should consider guardianship forever. I don't think that we can work a guardianship over, I would say, 10,000 years. Let me go to the end, to the outlook. What should be done? I think we should introduce a strong governance and a safety culture, which doesn't exist. There is a need for error correction and for reversibility of decisions. And I think what is absolutely central is that the concept of reactive waste disposal is completely false. And the idea to abandon waste is wrong. And here, fundamental conceptual change are needed. And naturally, the question will be how to deal with long-term stewardship. Next. I show you two pictures of stone axes or and what is interesting in these two pictures is that on the left picture you have very old axes or tools, and on the right you have this axis of the jüngere Steinzeit, this stone, the younger Stone Age. And between these two stages, you have 10,000, 100,000, and even millions of years. So the development, the technical development from this time of the left and the right was very, very slow. Next one. Now we are looking, for example, the drilling technology. It's the same thing. You see on the left side a photo of the spindle top, the first excuse me, the first drilling in spindle top in 1901, and the drilling technology from Herrenknecht. And this development take place during 120 years. So you see the acceleration of the technology in the last 100 years. And if you look next one to the, the acceleration in the last decades, you see wonderful examples of the typing machine and the computer. And what we chose that you have an absolutely acceleration of processes, but also of complexity. If you see the stone axe and you see a typing machine which integrates algorithms like language, or computers that integrate programming, the possibility to make a programmation, that is shows how the techniques became complex in our days. Next. And that shows also what we have to expect in the future. We will increasingly have a lack of anticipate developments and to make predictions. It will be more and more difficult to make, to anticipate developments. And that means if we have that, and I think there are not many people that thought on such topics, we have to create institutions that can answer and that can look and answer flexibly to these developments and to these uncertainties. And that is a basic goal for me of stewardship. And evidently, the essential governance issues is an independence of audit authorities, and the strategic maturity of concept must be ensured in a rolling process. Next. So the concept of reactive waste disposal and abandonment of waste is wrong, and there are fundamental conceptual change that are needed. Then solutions should only be implemented when we get inert material and not reactive material. And when we get stable, long-term stable wastes, the process must be validated by monitoring and not only by models, as actually with safety analysis. And that means we need during this time, and that can be hundreds of years probably, we need stewardship concept over at least, I said, several generations. Next. So we must develop error and safety culture. We must ensure early detection and error correction and reversibility of decision. For example, the question of bituminated waste, and that is a big governance challenge. I just remember there is no report I know until now that dealt with the history of errors of disposal practices. No report, no from IIA, no from NAA, no for governments or nuclear industry, no report on that. And that, I think that is a very good example that error and safety culture doesn't exist. Then the problem of intergenerational interfaces. Where are young people? And how should we go further on to form the next generation and to ensure the link in the change in the future? And that is a big challenge, I can say you, if I look at the examples that I know here in Switzerland, was very, very difficult to motivate young people to join, especially in the opposition. Then the problem of funding, we need money to train scientists and to pay them. And otherwise you would have young people that also join the movement. Next. So the final consideration, the implementation of disposal programs is extremely demanding and difficult and takes much longer than foreseen. And I think that is really, there's a multi-generational programs that need stewardship. And actually, I think nuclear industry is coming aware that these programs will go 100 to 200 or more years until they are finished. Then the implementation is one step. In one step is not possible. It needs several stages, but also basic regular reviews of the concept pursued and maybe the abandonment of the actual concept. Then the accompaniment of the process, like here's error of traduction is the pilot repository. So the monitoring is absolutely needed. No abandonment of waste until all basic problems are resolved. And the site communities and the critical scientists must be involved in such a process. And that means that the governance must be organized in another way. Next. Yeah. And that is just a picture that shows that we don't know where we are going. Thank you for your attention and excuse my English. I'm very sorry.